In this module, we look at DB2 400, the Relational Database Management System for the AS400. With over 525,000 installations worldwide, it has the largest base among database products. A unique feature of the AS400 is that DB2 400 is totally integrated with OS 400, the operating system for the AS400. This is unlike other database products that sit as a separate component on top of an operating system and have to be integrated with the other components. Database security is yet another important feature of DB2 400. Since DB2 400 is integrated into the OS 400, the same C2 level security that exists for the AS 400 is also applicable to the database system. DB2 400 also supports a high level of data integrity. It provides numerous methods to ensure the integrity of your data, such as journaling, commitment control, referential integrity, and triggers. Journaling is a method of recording all the changes made to a database. In case something does happen to corrupt the data, you can use the information recorded in the journal to restore the database to a previous stable state. In the journal, the system records the following information: the database file name, the name of the library in which the file exists, the relative record number of the record being accessed, the current date and time, the job identifier of the current job, the username, the workstation name, a copy of the changed record. Optionally, we also have a copy of the record before it was changed. Consider this situation. A bank maintains customer information in a master file. It uses another database file for handling loans taken from the bank. A customer takes a loan from the bank. Every month, the bank deducts the installment amount from his savings account and credits it against his loan account. This is done through an application program. Suppose the application program is running and it deducts the installment amount of rupees 5,000 from the customer's savings account. Suddenly, the system shuts off due to a power failure. The installment amount had not been credited to the loan file as yet. This causes an inconsistency in our database files. Commitment control is a technique that we can use to avoid such inconsistencies. It allows us to group a set of transactions together into a single unit of work. In case something does go wrong in between, the partial changes will automatically be removed from the files when the system is restarted. Referential integrity is yet another technique that we can use to ensure the integrity of our data. Here is an example. A company maintains its stock information in a master file. All requests for stock are first entered into a transaction file and processed at a later stage. Suppose the data entry operator enters an incorrect item code, the record would still be added to the transaction file. The error would only be detected when the transaction file is being processed. Referential integrity can be used to overcome such errors. We can place a referential constraint on the transaction file to prevent the entry of records that do not have a matching item code in the master file. Now, every time a record is being entered, The system will automatically check the item code and will signal an error in case the item code is not valid. A trigger is an action that happens automatically whenever a record is updated in a database file. Consider the previous example. When an item is issued, its stock level is automatically updated. Sometimes the stock level will fall below a prescribed reorder level, requiring that an order be placed for the item. Normally, an application program is run periodically that will check the stock levels of each item and reorder for items whose stock levels are below the reorder level. Instead of running an application program, we can code a trigger for the database file. The trigger will be fired as soon as the record is updated. This will activate a trigger program that will check the stock level of the item that has been updated. An order will be placed for the item if required. Let us now move on to the AS400 database file. Traditional database files are said to be program described. The data definitions are included in each of the programs that use the database file. Suppose you increase the length of a particular field. The change would then have to be reflected in each of the programs that use the data. AS400 database files, on the other hand, are externally defined. The data definitions are stored along with the data itself. Programs that need to use the data will only contain a reference to the database file. The compiler will pull in the data definitions from the database file when the programs are being compiled. Any changes that are made to the format of the data will have to be made only in one place, that is, in the database file itself. There are two types of database files on the AS400, physical files and logical files. Let us look at physical files first. A physical file consists of two parts. The first part contains the file description. This includes file name, file subtype, physical or logical file, record format, and access path. The file name and file subtype descriptions are self-explanatory. The record format describes the fields in the data record. It contains the following information for each of the fields in the data record: field name, data type, field length, usage, description, and column heading. For example, here we are describing a field ename that is of type alphanumeric with a maximum length of 30 characters to which you can both read as well as write data. We have included a description, employee name, and a column heading, emp name. Let us see what an access path is. When we add new records to the file, the records are normally added at the end of the file. When records are deleted from the file, the space occupied by the records still remain in the file. New records being added to the file will be put into these spaces. To retrieve a record from the file, we can specify the order in which the records are to be retrieved. This is called an access path. DB2 400 supports two types of access paths: arrival sequence and keyed sequence. In the case of arrival sequence access path, the records are read from the file in the same order as they are located in the file, starting with the first record. A relative record number identifies the location of a record in the file with respect to the beginning of the file. With a keyed sequence access path, we can specify a key field on which the records are to be ordered. For example, we can specify that the records are to be retrieved from the employee database with the employee names arranged in an ascending order. The second part of the physical file contains the actual data records. This part of the physical file can be divided into several portions called members. Each member can contain a portion of the file's data records. For example, a bank might want to keep each day's transaction as a separate member in the transaction file. Let us move on to logical files. Logical files do not contain any data. They are used to only view the data records that are in the physical files in formats that might be different from the way in which the records are actually stored in the file. For example, from an employee database, an application might require only a subset of the fields in the data records. Or perhaps an application might require only those records that match a particular criterion. Let us say only the records of employees whose date of joining is later than 1st January 1998. Like the physical files, the logical file also consists of two parts. The first part is identical to the physical file and contains the file description. The second part contains a keyed access path that has the key values along with the relative record numbers of the records that have been selected from the physical file. User interface. DB2 400 provides two interfaces to the AS400 database files. One, the data description specification or DDS interface, and the other, the structured query language or SQL interface. You can create, access, and manipulate the data in the AS400 databases using either of the two interfaces. One disadvantage with this dual interface is that both the interfaces use different terminology that could sometimes be confusing for the user. For example, the SQL interface refers to the actual database files as tables, while the DDS interface refers to them as physical files. Views in SQL are logical files in DDS terminology. Similarly, rows in SQL become records in DDS and columns in SQL are fields in DDS. As we had mentioned earlier, database files can be created using either the DDS or the SQL interface. With the DDS interface, we first code the description of the database file using an editor. The description is saved in a source file. We then use either the create physical file or the create logical file command to create the actual database file. With the SQL interface, we can use the create table and create view commands to create the database file. Adding records to the database file. Once the database file has been created, we can add records using a utility such as data file utility or through application programs. Here is a quick summary of what we have covered so far. DB2 400, the database system for the AS400, is totally integrated into the OS400. It has the largest installed base among database products. It supports a very high level of data security as well as data integrity. There are two types of database files on the AS400: physical files and logical files. Records can be retrieved from the database file using either a keyed sequence or an arrival sequence access path. There are two interfaces to the AS400 database files: SQL and DDS. Database files can be created using either interface. Data records can be added to the database file using the data file utility or through application programs.